Here's something that should make you put your phone down for a second, which is a deeply ironic request given what we're about to discuss. The average modern person reports feeling bored for approximately 131 days per year. That's not a typo. Nearly a third of your entire waking life spent in a state of mental restlessness, scrolling, switching tabs, looking for something, anything, to fill the gap. And yet there's growing evidence that for the vast majority of human existence, across hundreds of thousands of years of our species' history, this specific feeling, this particular flavor of modern misery, essentially didn't exist in the way we experience it today. Not because ancient humans were somehow less intelligent or less capable of complex inner experience, but because their brains, their daily lives, and their social worlds were structured in a way that made the specific neurological conditions required to produce boredom almost impossible to sustain for any meaningful length of time, which should make you feel either deeply reassured about human nature or genuinely horrified about what we've done to ourselves, possibly both simultaneously. Let's actually dig into why this is, because the details are considerably more interesting than the headline alone suggests. First, we need to understand what boredom actually is on a neurological level, because the popular definition, which is basically just having nothing to do, turns out to be almost completely wrong. Boredom isn't the absence of stimulation. It's a specific and genuinely uncomfortable mental state that researchers define more precisely as the desire to engage in satisfying activity combined with the inability to do so, despite the perception that the external environment should theoretically be capable of providing it. The key word in that definition is perception. Boredom isn't about what's actually available to you, it's about a mismatch between what your brain expects and what it's currently receiving. It requires, specifically, a brain that has been trained to expect a certain level and type of stimulation and then been denied exactly that. Which means boredom isn't a universal default state of the human mind sitting around waiting for entertainment. It's a learned condition, a product of a specific kind of nervous system shaped by a specific kind of environment. And the environment that produces boredom at 131 days per year is, to put it mildly, not the environment human brains spent 300,000 years evolving inside of. Let's talk about what those brains were actually doing instead. Researchers studying the cognitive demands of traditional foraging and hunting behavior have documented something that people who've never done it tend to dramatically underestimate. Tracking an animal through varied terrain isn't just a physical task. It's an extraordinarily cognitively demanding one. You're simultaneously reading ground disturbances, interpreting compression patterns in soil or vegetation, reading wind direction and what it means for your scent profile, mentally modeling the animal's likely behavior based on dozens of environmental variables, navigating terrain you need to be able to retrace from memory, monitoring the sounds and movements of everything else in the environment that might indicate danger, and holding all of this information in working memory at once, while also making rapid, probabilistic decisions about what to do next. Cognitive scientists studying the mental demands of tracking specifically have compared the real-time processing required to solving a complex logic problem continuously for hours, outdoors, with significant physical exertion layered on top, and with actual survival consequences riding on whether you get the answer right. That is not a mental state in which boredom is neurologically accessible. Your prefrontal cortex is simply too busy running calculations to generate the particular kind of underdirected restlessness that produces the experience of boredom as we know it. And tracking is just one task. Navigation in genuinely unfamiliar or varied terrain required detailed, constantly updated mental maps. Plant identification for both edible and medicinal purposes required a knowledge base that researchers studying traditional ecological knowledge have estimated at somewhere between 2,000 and 4,000 individual species recognizable on site with their associated properties, seasonal availability, and preparation methods retained in memory without any external documentation system available as a backup. Weather reading, social dynamics management, tool maintenance, site selection, fire management. Every single one of these was an active, ongoing, cognitively engaging process happening across the full waking day. The ancient human brain wasn't starved of stimulation. It was running close to capacity for most of its waking hours. Not because ancient people were somehow superhuman, but because the environment they were actually operating in demanded that level of cognitive engagement just to function at baseline. Now here's where it gets genuinely interesting, because you might be thinking, fine, but what about downtime? Surely ancient humans had periods of rest where they weren't actively foraging or tracking or building something. And you'd be completely right, they did. Studies on modern hunter-gatherer populations, who represent our best available living window into pre-agricultural human lifestyles, have documented this extensively. The famous research by anthropologist Richard Lee on the Kung San people of the Kalahari, work that was genuinely landmark when it emerged in the 1960s and has been revisited and refined significantly since, found that subsistence activities average somewhere around 3 to 5 hours per day, not 12, not 16, 3 to 5, meaning hunter-gatherers had, by most modern standards, a genuinely substantial amount of what you might technically classify as free time. And here's the thing, they weren't bored during it. What they were doing with that time, consistently, across documented traditional societies worldwide, was something researchers have increasingly come to recognize as one of the most cognitively and socially demanding activities humans engage in. They were talking to each other. Specifically, they were engaged in what anthropologist Robin Dunbar's research suggests may be the single most cognitively complex social behavior our species performs, managing the intricate, constantly shifting landscape of a small, dense, intensely interdependent social group where every relationship matters directly to your survival and reproductive outcomes. Dunbar's research on social group sizes in primates, which led to what's now widely called Dunbar's number, proposed that the human neocortex evolved specifically to handle the cognitive demands of tracking and managing social relationships in groups of roughly 100 to 150 individuals. Every person in that group is a constantly updating variable. Their alliances, their conflicts, their resources, their reliability, their emotional state, their opinions of you and your family. Managing this social landscape correctly, maintaining the right relationships, navigating status dynamics, building coalitions, resolving conflicts. It wasn't leisure in the modern sense of something optional and mentally low effort. It was survival-critical cognitive work that happened to look, from the outside, like sitting around a fire having a conversation. Which brings us to something that deserves considerably more attention than it typically gets in popular discussions of prehistoric life: storytelling. Researchers studying the role of narrative in traditional societies have documented what appears to be a genuine and near universal feature of human social life across cultures and time periods. Storytelling around shared fires, in communal spaces, during periods of rest, wasn't simply entertainment filling dead time. It was one of the primary mechanisms through which knowledge was transmitted, social norms were reinforced, group identity was maintained, and collective understanding of the world was built and updated. A story about a hunt that went wrong wasn't just recreation. It was a distributed knowledge update, a cautionary tale that encoded survival-relevant information in a memorable, emotionally engaging format that spread reliably through a group without requiring anyone to write anything down. And critically, it required active cognitive engagement from both the teller and the audience. Following a narrative, tracking its logic, integrating it with existing knowledge, responding emotionally, all of this is genuine cognitive work, the kind that actively displaces boredom rather than coexisting with it. Now is the right moment to address an obvious objection, because you can probably see it coming. Doesn't all of this just mean ancient people were too busy and too stressed to be bored? Which isn't the same thing as saying they had some kind of richer inner experience. They just didn't have the luxury of boredom because survival left no mental bandwidth available. This is a genuinely fair point, and deserves a real answer rather than being waved away. And the most honest answer is that the evidence suggests it's more complicated than either version of that story. Because here's the thing. If it were purely about cognitive overload leaving no room for boredom, you'd expect to find no evidence of prehistoric humans engaging in activities that served no obvious, immediate survival function. But that's not what the archaeological record shows. The Hohlefels cave in southwestern Germany produced a bone flute dated to approximately 40,000 years ago. Not a weapon. a musical instrument. Not a tool, a musical instrument. The Chauvet cave paintings in France, some dating to around 36,000 years ago, show not just animals rendered with genuine artistic skill and anatomical accuracy, but compositional choices, perspective techniques, and what appears to be deliberate artistic decision-making that goes far beyond functional information transfer. Beads, pigments used for body decoration, carefully constructed jewelry, elaborate burial practices with grave goods positioned with evident intentionality. None of these are survival tools in any direct sense. All of them are evidence of a species with inner lives rich enough to invest significant time and effort into expression, beauty, ritual, and play, even under survival conditions that modern humans would find genuinely extreme. Ancient humans weren't too cognitively overwhelmed to have inner lives. They were cognitively engaged in ways that naturally produced inner lives that didn't require manufactured stimulation to sustain attention or generate meaning, which points towards something worth sitting with for a moment, because it connects this entire conversation to something considerably more current and considerably more uncomfortable. Modern boredom at the scale we experience it isn't a sign that humans have finally achieved the leisure and comfort our ancient ancestors never had. It's increasingly looking like a sign that we've managed to engineer an environment that systematically defeats the specific cognitive and social conditions that made human mental life feel naturally rich and self-sustaining for hundreds of thousands of years. Constant availability of low-effort, high-stimulation passive entertainment appears to actively suppress the brain's capacity to generate its own engagement, in the same way that constant artificial lighting disrupts circadian rhythms that evolve to function under very different conditions. The mechanisms behind both are different in their specifics. The underlying principle is similar. Flood a system with a signal it wasn't calibrated for, and you dysregulate the system's natural function. Neuroscientist Sandy Mann at the University of Central Lancashire has specifically argued that boredom, ironically, serves an important cognitive function when it isn't suppressed at the first moment of discomfort. It's the brain's prompt to seek novel, self-generated stimulation, the condition that historically would have produced creative problem-solving, exploration, social connection, and artistic expression. But when that prompt gets immediately answered with a dopamine hit from a screen before the underlying creative impulse has any time to develop, the whole mechanism short-circuits. The discomfort disappears. The creative or social output it was designed to generate never arrives. Ancient humans sat with the discomfort long enough for it to produce something. A story, a song, a drawing on a cave wall that's still there 36,000 years later. An idea about where to find water next season. A conversation that maintained a relationship that kept someone alive through the following winter. They weren't bored because they were living inside the specific conditions that human cognition actually evolved to run in. Rich social connection, constant low-level, novel environmental stimulation, genuinely consequential cognitive challenges, creative expression emerging naturally from unstructured time, and no available mechanism to short-circuit any of it with something easier. We solved most of those conditions away, and then invented a word for what it feels like when the cognitive system those conditions were designed to sustain doesn't have what it actually needs to function the way it was built to. It turns out the cave was less boring than the couch. And the uncomfortable part is that we built the couch ourselves.